Yeah, yeah, I think it's
Yeah,
fun.
yeah, yeah. Why not? Yeah, that's some of the people they can join and they can. Then we can. Yeah. Now, as soon as I see it here, I will kind of like introduce us. Yeah. Now I can kind of see it. Not yet. Almost done. Mitchell, how do you do that with the background? That's awesome.
Yeah, yeah, I was also going to ask about that. It sounds really cool.
Yeah.
Looks great.
Okay, because you got that stuff. That's awesome.
Nice. Yeah,
Oh, that's great.
amazing.
That's awesome. So yeah, like now because we are live, so I gonna just kind of say hi everybody. Although there were like just 4 people in the chat, but that's fine. And then until we start with the talk, which is in kind of like 10 minutes, let's give a small introduction about ourselves. So probably I can start. So hi everybody, I'm Carlos, and I'm the co-organizer of GraphQL Hong Kong. And actually, I'm back in Spain. I was living in Hong Kong and Shenzhen the last year. And yeah, we started this in order, to promote community events in East Asia because there were not so many graphical events there. And it's been incredible so far. We had the conference, the GraphQL Hong Kong 2019, in September last year, and then we had the first meetup in December last year. And because of the coronavirus, we have to kind of postpone the on-site meetup in February to 2 days remote meetup. So hi everybody from everywhere in the world that you might have watched us. And yeah, this is gonna be kind of like an hour and a half, 2 hours meetup. Feel free to ask any question, anything that you might have. And yep, and yeah, I love GraphQL. So let's please, Mitchell, please, if you wanna just introduce yourself and let us know more about you and what is a engineers Singapore, why you guys are doing this live coding. I mean, like live streaming. Why are you helping us, and why are you helping the community in order to set these kind of events?
The meetups are usually happening and in the somebody's office or something. So
Yes.
through the recording, we hope to also create let people know more about the meetup, the content that's there, the meetup is happening, and then people who watch the videos hopefully can come and join the meetups in the future. Yeah, so we've been doing this for a couple of years. We also cover conferences. We cover monthly meetups from different user groups like CSS, JavaScript, Golang, and I have a team of volunteers, about
Awesome.
10 plus of us, who go around to different meetups to do this. And currently on our website, Engineers.SG, we have about 3,000 over videos. We've got 14,000 subscribers on our website. So yeah, so that's pretty much us. Mm. And why we're
Oh,
doing
that's
this is
awesome.
because of this virus thing. So we see a lot of meetups has in-person meetups have been cancelled. So I thought, if I since I have the technology and know-how, so why not just share it and with the community? And I think Carlos is one of those who approached me to cover this. It's actually our first overseas uh, a video call that we are
Oh,
recording.
awesome.
So this
Oh,
is
that's
pretty
that's
cool.
great.
So yeah, so yeah, that's it.
Yeah, I gotta add here that I met Engineer Singapore on a GraphQL Singapore and in JavaScript Singapore. So they were recording all the videos for free, and they were uploading the content after like a couple of minutes that I thought was finished. So that was kind of like live streaming, and that's incredible because in other cities you might not be able to find a group of people, the community that they are going to be able to record the videos because it takes time and also resources in order to do this stuff. So yeah, thanks so much for joining us. And then you might wanna give a kind of like a small intro then when we are starting the meetup at just like 12 o'clock GMT. But yeah, thanks so much, Michelle, for setting this up because even
No
for us,
worries.
as you can do a remote stuff, but you know how this works, you know how to set up stuff, you know how to resolve any problem that they might have, how to give access, how to like do everything. So that's really helpful for us in order to have this meetup going on. So thanks so much. Um, okay, Martin,
Yeah.
last
Okay.
minute speaker. So
Last minute
yeah,
speaker. Yeah,
yeah.
exactly.
Feel
Yeah.
free to introduce yourself.
Yeah. So my name is Marcin and I'm calling from Wrocław in Poland. Yeah, so basically I've been working as Python programmer for the last 5 or 6 years. And I work at a software house, Mirumi Software in Wrocław, and we mostly build web apps. And we specialize in e-commerce, so we use Python to build backend for that. We have a lot of experience with Django. Yeah, it worked well for us for many years, but now we switched to GraphQL and React for the front end. Yeah, we've been interested in GraphQL since like almost after it was open source actually by Facebook. Then we started looking at this, and I remember our first tries with Relay, which was for me really hard to understand at the beginning, but GraphQL seemed really cool. So we were digging into that, and now actually one of our main products that I'm gonna talk about later is like GraphQL is core part of this product, and now it's really it's driving like one of the driving forces, I would say, even for the development, for the like product development, and for like this entire thing. So this is really amazing. Um, yeah, so actually I started doing conference talks last year, and yeah, I my goal was to attend like Python conferences and Django stuff to talk about how do you do GraphQL in Python, because it's not so common. Yeah, I'm pretty happy how it turned out, and now I'm able to speak even on GraphQL Hong Kong, which is also really amazing. So thanks Carlos and thanks to Jesse for this whole thing. um yeah, that's it, I guess.
Yeah, that's awesome. I gotta say that I met Marcin in API Days Paris.
Yeah,
Yeah, right.
exactly, in December.
And yeah, your talk was incredible. So I'm like super looking forward to a yeah, like just like hear more about GraphQL and Python. That as Jesse was mentioning yesterday in Twitter, like there are not so many people that
Yeah,
they are expertise in the sector, but also the people that they are available in order to talk and share this incredible knowledge with the community. So
yeah.
yeah, thanks so much, Marcin. And then yeah, we can go to Roy probably. He's gonna be the second speaker, and you might introduce yourself if you want it, Roy. Can you guys hear Roy? Roy, I cannot.
uh,
Yeah, can you hear me?
Yeah, sure. Yeah, sorry.
yeah,
That's good.
Yeah, awesome.
Oh, so I want to introduce myself now. Sorry, I wasn't really.
Yeah, no worries. Yeah. So yeah, just feel free to introduce yourself and what you're gonna be talking about and who are you? Why
Oh
are
yeah,
you
so
working at
I'm Roy.
GraphQL?
I'm
Yeah.
working with GraphQL for like the last I think 4 years now, and most of my time I spent on working for the city of Amsterdam. Actually, work on their open source projects, and I'll be talking about how to test GraphQL servers and also GraphQL clients.
Are you calling? Sorry, are you calling us from Amsterdam?
Yeah,
Is
I'm
that
coming
right?
from Amsterdam. Yeah.
Oh, that's great. That's awesome. So Kartik, like now, if you want to introduce.
Sure. I'm Karthik. I work as developer relations lead at dgraph Labs, and dgraph is an open source distributed transactional graph database. And dgraph is the only natively supporting GraphQL database, which means dgraph interprets executes, stores, and even gives out native GraphQL API functions right out of the box. So I'm going to talk to you about how can one build GraphQL API functions for a Twitter clone in 10 minutes, just using GraphQL schema and dgraph. I'm dialing from Bangalore, India. It's great to be here. Thanks, Carlos and Tobias and rest of the folks who have made this event happen.
Yeah, that's awesome. Yeah, thanks so much, Karik. Like, yeah, we missed the opportunity to meet in graphical Asia, but yeah, hopefully soon we, as the community speakers, we will meet like somewhere else. I don't know. That'd be awesome.
Looking forward.
Yeah. So probably now, Mitchell. No, okay, Tobias. Can you see the? You can introduce yourself if you are around. If
Okay,
not,
sure.
yeah, awesome.
Yeah, hey everyone. My name is Tobias. I'm CTO at Brickell and also been working with GraphQL for a while now, for almost 3 years now. And I work at Brickell. We are a startup and we use GraphQL heavily and also involved in some of the events related to GraphQL. So Carlos and I, for example, have been working on the GraphQL Hong Kong meetup, and I've been organizing the GraphQL Bangkok meetup and also involved in the GraphQL Asia conference last year, and really spend my time in the GraphQL community to work with some of the services that we have and help to organize some events. And yeah, just be involved in the community as a speaker or organizer. And yeah, I'm really glad that we can make this happen remotely today. It's really exciting. It's the first time for us to do remotely. So bear with us if it's not perfect today. But thank you everyone for joining. I'm sure it's going to be a great event.
Awesome. Thanks so much, Tobias. Yeah. Yeah. I think I gotta say that it is difficult, to set up events like just like a single meetup. It takes a lot, a lot of effort in order to find speakers, find sponsors, find venues, and yeah, we were trying to find a venue or our like normal venue in Hong Kong, but for a I think normal circumstances because of the virus. Yeah, they decided that it's like safer, to just like don't host like on-site events right now in Hong Kong. So then we decided we got a proposal in Twitter. So we decided, why not? Let's try to do a remote event because the people they are interested to learn GraphQL, answer his their expertise in GraphQL. So yeah, here we are. So this is awesome that we could set up this stuff. Let's see how it's going, and hopefully we can like repeat it, whether it's going to be on site with live streaming or we can do other remote meetups. So thanks a lot for like to you all for being here and spend your time to share your incredible knowledge. And I think I'm gonna 1 minute so we can. I'm gonna start. I'm gonna just share my screen first, and then I'm gonna just do a quick intro to the talk, speakers, content, and then we start with Marcin in 5 to 10 minutes from now, I guess, or 15. So yeah, I'm gonna share my screen first. Let's see if there are more people joining us. Yeah, let me just quick share my screen here. I think I can do this, and I can do this, I guess. Can you see my screen, I guess?
Yep.
Awesome.
For me, it's black. But
okay, should be like GraphQL Hong Kong meetup too. Yeah, I think it's so out, right? I think like I'm gonna just ping Mitchell. Mitchell, anytime I might do question to you in order to see that everything's like displayed properly. But I think so that is displaying, I guess. Awesome. So okay, I think we are so it's 12 o'clock GMT. So we are gonna start. So hi everybody. Today we are hosting GraphQL Hong Kong, the second meetup. We have just done 2 of them. And today, because of the coronavirus situation, we have decided to host it remote. So thanks to that, we're going to have incredible speakers that are going to present shortly. And please go, I mean, like if you are watching us, you might be joining on Zoom on YouTube. Feel free to do both of them. I'm gonna be monitoring all the questions that you might have in the comments. So please feel free after the talks to do any QA, and then we're gonna proceed to answer that. And yeah, so today we have three incredible speakers. So we have first Marcin. He's the lead developer at Cellular. He's calling from Wrocław, Poland. Then we're gonna have Roy, senior front-end developer at City of Amsterdam. He's calling from Amsterdam. And also Karek, he's developer advocate at dgraph, and he's calling from Bangalore, India. We both, Carlos, that I am myself, and Tobias. So I'm calling today from Spain, and Tobias is calling from China. We are gonna be the organizer and the main people that are gonna be just leading this meetup. And yeah, we have. I want to just also like appreciate all the past speakers that we have before. So people from everywhere, from every single company, and hopefully we are gonna have more speakers soon. We want to really commit to have GraphQL events, GraphQL community events around the world. In this case, in Hong Kong. Um, so yeah, feel free to go to our website. It's graphql hongkong.org. And the agenda for today, we're gonna have a quick intro. So I'm gonna just do this intro, and also I really wanted to have a quick intro about the speakers, but also about the sponsors for today. And then Marcin, he's gonna be talking about real world graphene. So he's gonna be talking about GraphQL and Python, which is like extremely interesting. And then Roy is gonna talk about testing GraphQL from 0 to 100%. And to finish off, Karek, he's going to be introducing a bit of the graph databases, and building the GraphQL API for a Twitter clone in 10 minutes. And Tobias is going to close the event with some announcements. That'll be awesome, I guess. And hopefully the next meetup they are going to be on site with live streaming. We will keep doing remote. Okay, so let's go with the sponsors. So I really want to appreciate that Engineers.Singapore are helping us in order to set up this event. So they are live streaming, and they have set up all the stuff that we need in order to have this ongoing. So please, Mitchell, do you want to just let us know more about you in, I don't know, like a couple minutes?
Sure. Yeah. I'll just share. I got some slides. Maybe I'll just share quick slides.
Sure, yeah, yeah. Feel
If
free
I
to take the
can.
time to do it.
Let me just share it right now. Okay. Cool. Ooh, let me get the slides in. There you go. Okay. Yeah, so Engineers.SG is a not-for-profit community initiative that we created some years ago. So we created this as a way of helping document the Singapore tech scene, and basically you can watch all the videos that we're recording today. You can find them all on Engineers.SG. I've created a page just for this, so you guys can actually go there later to watch all the videos that will be we'll be recording tonight. And we all run by volunteers. So basically, these are some of the volunteers that we have. So all the Engineers.SG videos, you go to Engineers.SG, you can find all the videos there. It's about 3,000 over videos, all accumulated over 5 years. I also cover conferences, so you can find some of the tech conferences there as well. Those are based in Singapore. Yeah, and your volunteer today, that's me. So I'm Michael Cheng. I'm a software engineer. I'm based in Singapore. Yeah, so I'm really glad that Carlos approached us to do this, and we're happy to help out as and where we can. Yep. That's all I have.
Awesome. That's great. I was mentioned before for the people that they were inside of the live streaming yet. So I met Engineers Singapore when I was speaking in GraphQL Singapore and JavaScript Singapore meetups, and they are doing such an incredible job, which is just like by volunteers for free. They are going to any single meetup, doesn't matter if you're at Singapore, and I think now is the first overseas meetup that they are like recording. So they are going to meet up through meetup in the Singapore community events, and then they are like recording the talks, and they are like shared with the community, which is just incredible because personally I try to find a like volunteers or companies that they or like even like companies or offices that they were helping us to record the events, but it was almost so difficult or you gotta pay for it. As a community event, it's so difficult to afford that kind of stuff. So thanks so much, Michelle, for at Singapore, Engineer Singapore, for helping us out because without you guys, we couldn't have this event ongoing. So thanks so much.
Cool.
I'm gonna share my screen again. And then also I really wanna appreciate for Brickle because they are like Tobias is always like a super um, kind of like a commit to contribute with the community. So he's putting a lot of time in order to now, like create the content, create the cards, like do the promotion, like work on the website. So please, Tobias, do you wanna let me just stop my screen sharing, and then if you wanna please like introduce what is Brickle. Uh, yeah, I think
Okay,
here.
sure. Yeah, I don't have slides, but maybe just a quick introduction. So Brickle, we are building an e-commerce platform for custom products. So people can come in online and design customized products in the web browser. And that is all integrated with e-commerce and design studio with 2D and 3D. And we've been building this for a while now, and we started out with GraphQL. So we're kind of a GraphQL native and have been using GraphQL ever since and really never looked back. And that is also why we kind of got involved in the GraphQL community, because we wanted to share our experience and really be part of this community to learn more and share our experience. And yeah, we've been involved in some of the events in Asia and also in Europe. And yeah, we are really looking forward to contribute to more events, and yeah, really excited to see the talks today as well. Thank you.
Awesome. That's great. So to next, let's introduce the speakers. So I'm gonna try to understand how this works. So yeah, we can go just here. So please, Martin, if you wanna introduce yourself first, that'll be awesome.
Yeah, sure. So, hi everyone. Thanks for having me here, Carlos. It's really amazing that you're doing this event. So, my name is Marcin. I'm from Wrocław in Poland, and yeah, I'm a Python developer and Python and Django developer. I've been working with GraphQL for over 2 years now, and I'm a huge fan of this technology. Last year, I was doing some talks about how GraphQL works with Python because I think this is still pretty new thing in the Python world. So I want to share what we are doing because our company mostly uses Django and Python. So I want to tell people what are our experiences with GraphQL in Python, what frameworks are available, and what are their downsides or what are the benefits of using that in Python. Basically.
Yeah, that's great. Yeah, so you are the first speaker, so I assume you are gonna be just sharing all this incredible knowledge with all of
Yeah.
us. So Roy, might you introduce yourself? Yeah, Roy should be around. Just give a couple seconds. If not, Kartik, that I can see that you are there. So please, Kartik, like you can just introduce yourself first, and
Sure.
then we might go to Roy. Awesome.
I'm Karthik Rao. I work as developer relations lead at dgraph Labs. And dgraph is an open source distributed transactional graph database. And dgraph is also the only native graph database or native open source database which supports GraphQL execution right out of the box without any additional layering. So this means dgraph natively interprets, distributes, and executes GraphQL. So with dgraph, you can just get started just with GraphQL, and you can iterate just with GraphQL. You can even just scale with GraphQL. So that's what dgraph's all about. Pretty excited to be at this meetup, and thanks Carlos and rest of the team for making this event happen. Thanks for all the hard work. Yeah.
Yeah, thanks so much, Gareth, for introducing yourself. And I think that you are the first speaker, so like really looking forward to see your talk. That's gonna be great. Yeah, now we can go with Roy. Please, Roy, might you introduce yourself?
Hi, yes. So I'm Roy. I'm here from Amsterdam. And most of my time I work for the city of Amsterdam on their open source projects. And today I'm going to be talking to you about testing GraphQL.
Awesome, that's great. I can hear like a bit of echo, so then before your talk, right before your talk, we can do a just like a quick audio test in order to see that
Oh, yeah, sure.
everything awesome. But that's great. Thanks so much for joining us, right? So yeah, we have like 4 minutes. So basically, I wanna just take those like 3 minutes before starting the meetup with Martin to say that yeah, thanks to everybody's, thanks to the people that are joining online, for the speakers that are here, for the sponsors, and we are gonna try to keep those events as much as we could. So hopefully the next event is going to be on site, and then we're going to try to we will post all this video later, so there is the live stream that is going to be recorded in YouTube, and everybody's going to have access to those talks. So that's going to be great. Also, please go to Engineers Singapore to find the content as well and see. I think the Mitchell, he has mentioned that there are more than 3,000 talks, and that's awesome. So I'm pretty sure there are like such incredible content there as well. And and yeah, so it's important that in order to keep these events happening, we need sponsors. So if your company are interested to contribute to graphical community events, please reach us out in info@graphql-hongkong.org. And it will be an honor and a pleasure to promote you guys, and like just let the people know who is interested on maintaining and keeping on going these GraphQL community events, because it's just a small community, but I think that we are doing pretty good, and we are like growing very fast in the last 2 years. So it would be really great to see more people from everywhere in the world being able to share their knowledge. And that's, I think, like remote meetups, they are doing a really good job, because we can just like jump from India, from Europe, from Asia, from hopefully soon from Africa, from Canada, US, Mexico, whatever. So that'd be awesome. So okay, I think that we might start. So Marcin, please, if you want to kick off the meetup, that'd be great. And yeah, feel free to start your screen and see that everything looks correct. And you feel free to start whenever you're ready.
Cool. So can you see my screen?
Yeah, everything looks incredible. So yeah, I think
Okay, cool. So I think
ready.
start. So again, hi everyone. For those who just joined, my name is Marcin, and today I'm gonna talk about building GraphQL in Python and Django. So my talk is called Real World Graphene: Lessons Learned from Building GraphQL API on top of Django app. Yeah. So to quickly introduce myself, my name is Marcin, as I said. Yeah, I come from Wrocław in Poland. I work as a Python developer here at a company called Mirumi Software. We are a software house specializing in e-commerce, but we also do other web apps with GraphQL and React. We use Python as a backend mostly. And for the last 2 years, I had the pleasure to be a lead developer at a project called Sailor, which is like one of our most important projects right now. Yeah, so what's also important here in Wrocław, we are doing GraphQL Wrocław as well. I didn't mention that before, but this is also something that you might be interested in. Anyone listening to this event. So yeah, we have our own meetup here as well. We have quite many members there. Like on every meetup, we have like 100 and 150 people. So it's really big community of developers here in Wrocław in Poland. So uh, if there is anybody else like interested in joining us and speaking at our event, it would be great. Just contact me. Yeah, so I want to introduce you to Sailor because this is pretty important in the context of my presentation, because like this project is where we start the journey of GraphQL. So Sailor is basically an e-commerce platform. It's open source, so you can find it on GitHub. And well, I'm it's it depends how much familiar you are with e-commerce, but I'm sure that many people heard about Shopify or Magento, WooCommerce, stuff like this. So Sailor is something similar. You can think about Sailor as Shopify but open source, or for example Magento, but built with a little bit different technology, because like we use Python, which is at the very core of our platform. Uh, we believe that this makes our product um, like better in terms of code quality, for example, because this is open source product, so it's really important to have good code quality there. So this entire platform consists of few parts. So this is a screenshot of the dashboard application. So this is where you manage your shop. Basically, this is a front-end app built in React. It's using GraphQL underneath. Um, Here we have the storefront application. So this is a kind of template of a shop that you can take from GitHub as well and build your shop using this template. And few facts about our API, because all of that is powered by GraphQL API. So we have now about 50 queries, 200 mutations, and 500 types. So this is like few statistics to give you an overview about size of the API currently. We have JSON Web Tokens based authentication and permissions system. From like the more cool features, we have service accounts and webhooks. So this means that you can not only use that API for your front-end apps, but you can also build integrations like other services that can authenticate in our API and fetch some data or get some notification by webhooks. So this is really cool. And what we really like about our API is also that we have pretty unified way of filtering, sorting, and search in all top level queries. So these are a few facts. Actually, I have like the running app on my machine, so I think it can be interesting to see how it looks like. So this is the dashboard application. Um, this is where you manage your shop. Here's, for example, the list of your products. You can go to product details and do some kind of management here. We have orders management, customers management, and all kinds of features that you might need in e-commerce. What might be interesting for you is that, as I said, it's all running on GraphQL. So if I reload this, then you can see that there are some GraphQL requests underneath. Like for example here, yes, that's data from our e-commerce API. So in this case, we are getting, for example, customers data. Um, yeah, so this is pretty exciting. This is like huge React app that works really well here with GraphQL. Uh, Here is our storefront application. So as I said before, this is just a template of the shop that you can customize. And it's also a single page app. It's using GraphQL underneath. And here we have also the playground. So if you don't need any front end, you can just use this API, for example, to get data of your products. So for example, here is a query to get product from my shop. So for example, I have apple juice, and here I have a bunch of variants of that product. So yeah, so this API gives you access to all kinds of e-commerce operations that you might need. So you can use it standalone, or you can integrate that with your existing solutions. So if you are interested, um, we have, so this is all open source, as I said. Um, so go to github.com/mirumi/sailor if you are interested in using this. We also have public demos, so if you want to just try out without installing it locally, then use that demo to play with the platform. So I'm talking about this entire application because that's where our journey with GraphQL has started. So this entire app was initially built as a Django, like purely Django project. So for those who are not familiar with Django, this is like classic framework where like you have model view controller pattern. So it's all a huge monolith where like both front end and backend lives in the same code base. So that was fine for us for a few years at the beginning, but at some point you start to realize that if you want to introduce some extensions like integrations with other services, then you might need API. And we had no API before adding GraphQL. And also you will notice that maybe those static templates that you have in Django are not enough to build a first-class user interface with dynamic features. And like modern apps have really complex UI, and this is not achievable with static HTML templates. So after having this Django-based architecture for many years, we decided to add GraphQL layer on top. So this is what we've actually ended up with. So on top of our Django ORM logic and all the Python logic that does the business stuff, we've added GraphQL layers. So it's built with graphene. And we've moved all of our, like two of our front-end apps um, outside of the project, of the core. And now they are separate apps built in React and Apollo. And they use GraphQL as you've seen in this short demo before. So this is like the new headless architecture, which also allows us to build external integrations around the platform. So this is a really great benefit of having API and especially GraphQL API here. So yeah, as I said, we are using Django for the backend. And when we started doing this transition, it was like 2 years ago or something like that. The only framework that was available was Graphene, and it's still the most popular framework for doing GraphQL in Python. So we are using that currently. Um, yeah, it's a code first framework. So um, we are building GraphQL with Python classes, Python functions, and the schema is generated from that. And yeah, Graphene has support for popular Python web frameworks such as Django or Flask, but you can also use it standalone, let's say, if that's your use case. So in this matter, this is a pretty flexible framework. So yeah, basically now I'd like to share a few lessons that we've learned over those 2 years of using Graphene at Sailor that you won't necessarily learn from the docs, or you wouldn't necessarily know after a few months of playing with the framework. Yeah, so let's start with like maybe one of the biggest benefits of graphene in my opinion. So the first lesson is that Django plus graphene lets you rapidly build APIs. So it means that this duo of Django and graphene is really powerful if you want to prototype something very quickly, or if you have large existing code base and you need to add GraphQL on top of that. So let's see why it's like that in graphene. So yeah, let's look at how we define data in Django. So this is a simple class that represents a user. Um, yeah, so I think that it's pretty similar in many other frameworks as well. We have a bunch of fields here. We are using Django ORM here to use some fields like emails, booleans, or datetime. So this class would be later transformed to a database table, right? So this is how most frameworks work, I suppose, that support ORM solution. So we had a lot of models like this in our code base. And now if you want to represent that in GraphQL, what would you do in Graphene? In this framework, we are building simple classes like this one. So again, this is called user, this class. And this is very simple because here in this meta class, we are saying that we want to map fields from the user model. And by using this Django object type here, this class would magically uh, like use those fields from our model in our type. Here we can specify which fields exactly we want to map. So this reduces the risk of accidentally leaking some private fields, for example. So you need to make sure that you have only the fields that you want here. And basically that's it. That would out of the box also generate all the field resolvers for us. So this is pretty convenient. To bind this type to the schema, we need a query. So this is how we define queries in Graphene. Again, we are using object types, and here we define, this is the listers, it's using the user type, and we also have the resolve users function, which just takes all data from the database and returns that in this query. So these few lines of Python code would result in this schema. So that's how the code first approach works in Graphene. It's, as I said, it's pretty convenient if you have existing code base and you are adding GraphQL on top of that. So that was exactly that's what was our case for using that. So to summarize that, mapping models to types in Graphene is effective if you are building on top of existing code base. Um, you have full control over the field resolvers, like they are mapped automatically, but you still can control like how they behave. If you want to add some permissions, for example, to a particular resolver, you can do that easily. And what's also important here is that Graphene uses syntax, like style of programming that is declarative, which is very similar to what you do in Django. So if your team is starting with GraphQL and uses Graphene, then it's really easy to dive in because you have the same programming style, the same patterns used in both frameworks. So this is really convenient to use. So that's the first lesson about building types. Um, so now let's talk about mutations. So it seems that after building all of these mutations in our API, it turns out that mutations are a bit more tricky in Graphene, and this is not so obvious how to do that right when you start doing this. Um, so let's see how you build mutations by default in Graphene. Um, yeah, because I'm talking about Sailor, which is e-commerce platform, I have examples here like this one. So for example, creating a product. Uh, so what is going on here? We have a class called create product. What is important in Graphene, every mutation is a class in this framework. So here we specify the input data in the class arguments. Here we specify the output of the mutation, so fields that would be returned as a result. In this case, we want to result a new product. And here is the actual body of the mutation, so the resolver. So here we say what should happen when this mutation is called. And in this case, we are just getting data from our input. We are passing that to the model instance and saving that in the database. So this is like very simple example of how a mutation would look like. But in real life, if you have a lot of operations like this and many business rules, this is usually more complex. So first of all, there is no common pattern for input data validation. So for, like pretty often you want to have some business rules on the input that you are passing to the mutation. There are some constraints that you need to check before saving data. So there is no like easy way to do that in Graphene, or maybe let's say like it's not obvious how to do that well when you are starting. Second problem is that there is also no established pattern to return errors in Graphene. So if we have some validation errors during the mutation execution, there is like you as a developer have to figure out how to return those errors efficiently, and you have to establish your own patterns. It's not given by Graphene. Like so this is kind of problematic at the beginning. And if you have a lot of mutations like this, and you add all of this business logic here, this would result in pretty large classes. So you would end up with a lot of boilerplate code. So we had to fix this somehow, and what we did is we introduced few abstractions. So these abstractions are not provided by Graphene by default. Um, I mean, there are some abstractions that, for example, allows you to migrate from Django REST framework, which was like most popular framework for building REST APIs, but not if you are starting with pure Django app. So here I want to show a few patterns that we've developed over the last 2 years. So let's start with unified errors handling in mutations. So we have this little abstraction called base mutation, and yeah, so here are a few things going on. First of all, like we've added our own resolver for that mutation, which is called perform mutation. And as you can see here, we are calling this resolver inside the default resolver provided by Graphene. So, and this perform mutation function is wrapped with try except block, which basically looks for any validation error that could happen during execution of that mutation. And it does some job to format it nicely. So we don't have to care at this point what it does, but like this is like one of the responsibilities of this base mutation class. And here, as you can see, we have the errors field. So now every mutation that extends this one, this base mutation pattern, would get this error field as one of the output fields. So if we use that constantly across our code base, we have unified error handling, because now every mutation has like very similar shape, um, which is what we want to have. Um, yeah. So for example, if we take again this product create mutations as an example, so you can see what we have here. We have some input data, and below we have the errors field. And for every error, we are returning field, message, and code. So field tells us which input field uh, resulted in an error. Message is actually meant for the developer. It's not to be displayed in the front end. And that's what we used to do, but actually it doesn't work in the long run, because usually you have your translations in the front end code and not in the back end code. So you cannot show those messages in the front end simply. So for that, we have those error codes. So front end is supposed to interpret those codes. And because these are enums, so for example, here is the response, the error response. So for example, we have codes like unique and some field name. There is constraint that it must be unique. And now if you have a bunch of codes like this, and they are enums, so they are defined in the schema, front-end developer can handle that easily and display proper message in the front end. So having those base mutations allows us to do that in every mutation that we have in Sailor. So this is pretty cool, and that's something that wasn't available in Graphene by default. Um, yeah, in our case, you've seen we have this dashboard application, which is basically large CRUD app, uh, because there is like a lot of views where you have just create new products, create new categories and stuff like this. It's just a lot of mutations that create and edit stuff. So and if you are building these mutations, you will quickly find out that they all follow the same pattern. So first you want to clean the input data, because you have some validation rules. If this data is fine, then you want to create the a model instance from that data. Then you want to validate it again, maybe, and lastly you save that to the database. So we had a lot of mutations that followed exactly these 4 steps. So what can we do to make it easier to add these mutations? So we've developed another abstraction called model mutation. um, I'm not gonna show the source code of that, because that would be maybe too difficult to understand on such short talk, but uh, this is just to give you idea how it looks and how it works. So we only say that this mutation uses the product model, and inside it knows how to, yeah, and it also takes the input object as an argument. And inside it knows how to clean the object, because we have the validation rules defined at the model level in Django. And it does all the magic to generate this simple product create mutation. And it's very powerful because if you want to override particular step of for example, this flow that that we've seen on the slide before, there are just a bunch of methods that you can override and customize this flow. So we have types, we have mutations. So what about subscriptions, which are one of the most powerful features of GraphQL? So it seems that if you are using Django, there is no native support for subscriptions, unfortunately. Um, so the thing is that Django, as I said, is kind of classical MVC framework, and it was also designed for this request response pattern. So it doesn't handle very well asynchronous connections, such as, for example, um, sorry, I lost the word, not webhooks. Yeah, anyway, asynchronous connections. So this is a synchronous framework, basically. And for example, database access is synchronous, and there is no way to change that currently. So that's a huge blocker. So we cannot have subscriptions because of that by default. But there is a solution called Django Channels, which wraps entire Django application with additional layer that is able to process async requests. And this is still pretty new thing. It's not so common to use, so not many people use that actually. And yeah, so technically it would be possible to have subscriptions with Django. We haven't tried that because we yet haven't like use case for subscriptions in our application, but that's how it looks like currently in Django and Graphene. Um, yeah, so this is database sync to async is kind of one of the tools you have to use with Django channels to have access to the database. Um, so this is kind of possible, but it's also a third-party library. It's something unusual, so yeah, it's kind of problematic in Django to support subscriptions currently. So this brings us to the fourth lesson that we've learned, that if you are building fully fledged API in Graphene and Django, you need a bunch of additional libraries. Um, so for example, uh, I said before that we support JSON Web Tokens for authentication, and that's true, but it's not provided by Graphene by default. You need additional library for that. Um, Also, to have permissions management based on JSON Web Tokens, you also need, like, it's the same library basically, which is fine because you can have this feature, but there is always a risk with using third-party libraries because you will never know if they will be maintained, because very often they are maintained by one person and or very small team. And yeah, it was problem for us a few times already that we have to be dependent on some kind of library that it's not supported. The same is for Apollo Federation. It's also not built into Graphene by default, but there is one library that can give you this feature. Um, Also, file upload. I know that file upload is kind of there is no agreement on how to do that well in GraphQL. There are a few patterns. Uh, for us, we wanted to have the basic file upload through a mutation, and it is possible to do that through multi-part requests in GraphQL. But again, to support that, you need another small third-party library in your stack to have this feature. Some features are actually not implemented at all. So, for example, query cost analysis, which is a feature available in Apollo server, for example, but in Graphene, it's not available yet. There are some open issues about that, and actually I'm not sure what's the state of those issues, and that would be pretty useful in our case because you can use our API in the like headless solution. So we need to support query cost analysis at some point, and probably we will have to build support for that ourselves. So these are like the 4 lessons that I've prepared. There would be much more stuff, but I think these are the most important ones. So we've seen that there are some benefits of Graphene, but there are also some downsides. So you may be wondering, why do you guys use Python? because there are some really well solutions on the market, such as Apollo Server, which is probably one of the best GraphQL servers out there. Um, so why don't you just migrate to Apollo Server, since you've had to migrate your entire architecture? Yeah, that's a really good question, and we've been asking this question ourselves. And the answer is pretty simple for us. So the answer is that we are huge fans of Python, and basically we decided to invest more time in this language and GraphQL support in this language. And that's why we started using Graphene, and now we are actually developing our own framework. Um, yeah, and what I want to show here is also how the modern Python looks like. So for example, this is Python 3.8. So the newest version now. So you have async await support in Python. So you can do all of the asynchronous stuff right now. So it wasn't available when Django was created, for example, but now it's totally doable. So we believe that Python is growing, and actually there are proofs that Python is growing, because that's how it looks like compared to other languages. Because of data science, machine learning stuff, where Python is very popular, and also web development, Python is growing really strong nowadays. So this makes us believe that it's really worth investing time in developing solutions for GraphQL in Python. So last thing that I want to show you is Ariadne. So this is our own server for GraphQL that was inspired by Apollo server. Is a schema first framework, and it has all the async features plus subscriptions. Um, it's still quite early for that framework, like early days, because for example there is only very basic integrations with Django. So probably adding support for that is on our roadmap, but you can use that already to build, for example, federations, and we use that as well. And yeah, it's really cool framework, and we want to invest a lot of time in this. So we believe that it's really worth to do in the Python community. So that's all I have. Thanks for listening. Uh, I'll be happy to answer any questions if you want to know more about this.
Um, thanks so much, Marcin. It was an incredible talk. I really liked how you describe a lot of like different features about GraphQL with Python, and that's great because I do know that there are not so many people that they can touch different topics in the API architecture and like give that information to us, to all of us. So that's great, and thanks so much. So we do have a question in YouTube. Sri, sorry for the names, like if I can pronounce it correctly. Sri Reddy, he's asking about, he has two questions. So one is how we can handle file uploads via GraphQL in Django, that I think that you have
Yeah.
discussed a bit about it. But then he also has another question, which is that he's using the Django GraphQL GWT for authentication, how he can use the same GWT for normal Django views authentication. I'm not sure if I totally, you can totally understand the
Sorry.
question, but you can give a like a general overview about your experience with file uploads and GWT authentication
Yeah,
with
yeah, yeah.
Django.
So okay, let me. So there is basically one library for file upload in Graphene, which I need to check out the name because I don't remember now. It's called probably. Sorry, let me Google that really quickly.
Sure.
Mm, okay, I don't have it right now, but if you Google Graphene file upload, there is one library. Yeah, it's basically called Graphene file upload, and what it does, it defines one mutation which you can use to upload files. It also provides the GraphQL type, which is called upload, and you can use that to represent your files. It's a little bit complicated to test because you need to build this multi-part request somehow, and it's hard to do in tools for like it's not possible to test in Playground, for example, unfortunately. Um, I think you can use Insomnia or Postman to test that, or um, you can do that in the shell in console if you like, but probably people use Insomnia or something like that, and there you can test those multi-part requests. Um, if can I share the link somewhere here?
Yeah, sure. Yeah, you might feel free to share it in YouTube and also if you want in Twitter. But
Yeah,
yeah, also in Zoom here.
yeah. So because I'm not on YouTube, I'm only here on Zoom.
Yeah,
Uh,
I can send it.
so that's the library, and there are also examples of how to actually build this. Sorry, not in this repository, but okay. So I'll post another link, which is GraphQL multi-part request specification, and uh, this is a specification of how the multi-part request should look like. Yeah, so that's the problem. Yeah, like it's not so easy to use, but it works for us. For example, in our dashboard applications, we have upload of product images, and that works perfectly well. The other approach of handling file uploads is uploading directly to your storage, for example, Amazon S3. Um, so you are not doing this through your API, through your GraphQL API, but in some other way. That's the other approach that I know, but we haven't used that in our project yet. And there was also
Okay.
second question about JSON Web Tokens, but I don't remember exactly what was it about. But I can quickly share just one more link for uh, for a library that we use, and this and this again, if you use this, it gives you access to few mutations like token create, for example, which creates a token based on credentials that we provided. There are also mutations to refresh the token. So here's the link. Um, and yeah, we use this library for that.
Awesome. Yeah, that sounds great. So like really good resources. So I send all the links to YouTube. So you might link later with that person that he asked you the question, and I don't know, you can just have a quick chat about a Python, graphene, a GraphQL, which is great. So yeah, Marcin, thanks so much for joining us from Rosa, Poland, and a yeah, looking forward to knowing more about what you are doing in the community, like giving talks, like what you are guys are doing with journal libraries in Salior. So that looks super promising. So hopefully we're gonna know soon more stuff about that. So thanks
Thanks.
so much
Thanks.
for joining. Okay, up next we have Roy. So I guess I can see here that he's ready. So yeah, Roy, feel free to share your screen, I guess, and start with your talk, of course.
Yes, will do.
Yeah, the
So
audio
I
is
think
great.
you. Oh yeah, do you see my screen now?
Sure, everything is great, so you can go for it.
That's good. So hi, thank you all for being here. If you've missed my introduction, so I'm Roy. Um, I work and live in Amsterdam, and I'm going to tell you something about testing GraphQL. So before I'm actually going to tell about what testing in GraphQL could look like, I'm going to ask the question, who's this talk actually for? Because a lot of people I know, they actually don't test their code. So they either test the code in production or they test it just by clicking some buttons and then pushing their features to production. So I'm not saying you should test your code with code. You can also have manual testing, or there are services to help you with testing. But you should always think about how to test your code. So, like I told you, I'm Roy. I live and work in Amsterdam, and most of my time I spent on working for the city of Amsterdam, where we develop open source products. And we also develop some GraphQL servers built on top of internal APIs. And I also work with some other companies, and you can find me on Twitter with the handle @GetHackTeam. So if you've got some questions after the talks that you couldn't ask in the live chat, then make sure to find me on Twitter. So why write tests? So there are multiple reasons to write tests, and it isn't only to be sure about your code, but there are also actual reasons to test your code. So One of the things I really like is check if code behaves as expected. And this is something you can do in a lot of ways because it's really simple to test simple code. So if you have a function that sums up two numbers, it's really easy to test that code behaves as expected. But if you have a function that um, calls other functions, maybe it is a composed function, or maybe it's even an entire UI, you want to make sure if the code underneath this test is behaving as expected. And something else I really like to do is check if errors and edge cases are handled correctly, because a lot of time I write like error messages in my code, or I have edge cases that I don't really document. So if you don't document them, probably the next developer working on the project, or maybe even yourself if you look at the code after a year, maybe you don't even know what the code is about anymore. So one of the things I really like writing tests for is for errors and edge cases, because edge cases should really be documented. And there are more reasons to test your code, right? So other reasons are making refactoring easy, and especially if you're not using something like TypeScript, just like plain JavaScript, or maybe even like Python. If you start refactoring your code and you don't have any tests in place, it's really hard to make sure that the outcome will be the same. So I talked about the edge cases just before. If you have edge cases in your code that aren't defined somewhere, like in documentation or in tests, and someone start refactoring, then there's a really big chance those edge cases will get lost. So the next developer will probably write new code, refactors everything, and then maybe that one moment when someone pushes a button from a certain location, your edge case will be gone. And yeah, so it also improves your code quality, in my opinion. So if you're working with code reviews with team members, then probably your codes get better after every review. If you're writing tests for your code and it's really hard to write a test for your code, then probably your code is hard to read. So if you don't have someone to review your code, you should definitely review your own code by writing tests and see how easy it is to write a test for the outcome of your code. And the same as I told about the edge cases, tests can also be documentation for your code. So improves your code quality, right? Because who likes debugging? And about the documentation, it can really serve as documentation because if you look at this function, so this is from a design library I've been working on. So you're going to import some functions and then you're going to test these functions. And then you can actually write down what your test cases are. So maybe your test case is to check if it returns undefined, maybe it should throw, maybe there are other test cases you want to be in there. And especially if you're familiar with test-driven development, and something like this is really helpful because test-driven development is going to help you document your code before you even write the code, which is actually a really great approach. And this is something you can have for GraphQL as well, both server side and client side. But we'll have a look at that. So what can we actually test when we're testing GraphQL? So we can test schemas, right? Especially if you're working with schema first designs, or maybe you're programmatically creating your schemas, then you should definitely test those schemas. So you want to know if your field is actually a string or a number before it goes to the GraphQL query. So you don't want to test your schemas on runtime because it's going to throw errors. You actually want to test your schemas maybe in compile time, or maybe even just when you're running your test and you're pushing your code to production. So these are ways to test your schemas before actually having users use the schema. And you can also test resolvers, right? Because if you're familiar with resolvers, and you probably are, unless you've only been using GraphQL client side, but you can test resolvers. Resolvers are just functions. They're either async or they're synchronous. They probably have promises in there, and they're probably going to make a connection with a database, external services, maybe internal services. And these are things you can test. So you can test if your resolvers are collecting the right data for your responses as defined in your schema. So you should really have a separate look at testing schemas and resolvers because they're doing different things, but in the end they can come together and they can be the same. They can share the same tests. And are there more things you can test on server side? There probably are, right? Because maybe you can also test performance of your GraphQL server side, and maybe do a performance testing, see how many concurrent users you can have, what will go wrong if you're sending the same query like 8 different times, or maybe sending the same query with 8 different arguments. So these are all things you can do with performance testing. Or, like I told you, you can test it client side. And this might be really interesting to test it client side because in that scenario, you're not actually testing GraphQL or how GraphQL works. You're more testing if the libraries or packages you're using for GraphQL are working as expected. So, but how to test GraphQL? So, I want to test schemas, resolvers, and maybe we want to test how schemas and resolvers work together, right? So, how to actually test this? There are multiple ways. So, one of those things you should have in there is static type checking. With static type checking, maybe with TypeScript, or maybe just by utilizing the schema itself, you can make sure that there won't be any incorrect fields in your schema. And also unit tests, like the resolvers I told you about, they are functions, so they could be really easy to test with unit tests. And maybe your resolvers will have helper functions or utilities. Those probably are really good to have unit tests. And the integration test is for situation where you want to combine your schema and your resolvers and see if they really have the correct outcome as you expect. So maybe you're going to have an integration test that's actually checking your schema to your resolver and then maybe even sending a query or mutation with it. And then where you can test the entire flow or parts of the flow, which is very similar to end-to-end tests, right? Because you can imagine there might be an end-to-end test where you're testing something client-side. So you're requesting a query client-side. This query is going to be sent to your server, and your server should be handled with the schema and the resolvers. So that way you're probably testing the entire chain for GraphQL, both client and server side. So that could be an end-to-end test. So the strategy for testing, and probably if you're really into testing or you've read a lot about testing yet, there are different strategies to test your application. No matter if it's a server or a client, there are different ways to test applications. So one popular approach is the pyramid approach. That is probably the oldest one, just as pyramids. It's a pretty old approach for testing software in general. And there is also uh, the reverse pyramid. So both are actually patterns you could use for testing. And let me tell you about the first one, the first pyramid first. So this is like the traditional pyramid of testing. And as you could see, it's a pyramid. So at the bottom there's a lot, and at the top there's less. So usually you would have type checking like right down the middle, right below the middle. Because type checking is important, it's really easy to do a lot of type checking, and it runs pretty fast. And next to type checking, you also have unit test in there. So unit test and type checking, according to the traditional pyramid of testing, they should really form the basis, like the fundament of your testing pyramid. And then in the middle, there will be integration tests. Because integration tests, they're a bit harder to write because you're actually going to connect multiple services or pieces of code. And that's why they also run slower. You're not testing a single function or a single object. You're testing multiple functions, how they work together, maybe even doing some front end and back end at the same time. So integration test, you can test like it's more mission critical. It takes longer to run. It also takes more time to write. They're definitely helpful. And at the top, you can find end-to-end tests. And those are really testing your entire chain. So you can imagine these tests are harder to write. They run really slow. So that's the pyramid of testing, right? So you have a pyramid, unit test, integration test in the middle, and at the top, you would have end-to-end testing. And then you could have a reverse pyramid. And this is actually, if you talk with business managers, they probably really like the reverse pyramid because reverse pyramid, there's a lot of end-to-end testing. So if you're asking non-technical people and they want you to test your code, they probably say, yeah, we want to test if someone clicks on my checkout button, if they will actually buy the product. But that's something, it's really hard to really test this real good because someone clicks a product in your client, it's going to send requests to servers, it should resolve, it should give information back. So if you're really technical, you probably feel this is an anti-pattern. If you're a business manager, you probably really love having a lot of end-to-end testing in there. And then quite recently, or maybe like a few years ago, a new pattern erupted for testing. So out with this anti-pattern, and a new pattern came in, which is actually, this is a Champions League of testing. So this actually is a Champions League trophy, I guess. And actually, the idea about this, at your very core, it is static type checking. So static type checking should be at the base. You would have some unit tests above, and you have a lot of integration tests because integration tests, they are important. Integration tests actually test multiple pieces of code together, and end-to-end tests, they're at the top. There are some less end-to-end tests, but there's still quite a lot. that basically what this pyramid is, what this trophy is saying, every type of function should have their own sort of testing. So you can't test all your code because the coverage of 100%, it's really hard to get there. And also integration tests, they're more important because you can test if one function works, you can test if the other function works. It doesn't really mean that both functions will work together. So there are different types of testing, and for GraphQL, I actually like this approach. So you can split it around. There are multiple use cases. Resolvers have their own kind of testing. You should definitely test resolvers and schemas together. Maybe you shouldn't test whenever you're sent a query if your resolver is being called right, because your schema can probably handle it. So let's start by looking at testing schemas. And testing schemas, you can do them a lot of different ways. Something I really like with testing schemas is you can actually check if your product type, which I've defined on the left, actually matches the product type as you want it to be. So I'm not sure if this test actually says something because you're just testing if of your abstract syntax tree from GraphQL on the left side is equal to the right side. So this is a test you could make. I'm not sure if you actually get real advantage out of this test. So for bigger schemas, there are other ways to test it. And one of the packages I really like for this is Easy GraphQL. And Easy GraphQL is actually made by someone who works for Cypress, so he's really into testing. And it's really easy to install as well because it's just an npm package. And you can use it for mocking, for test assertions, so you can test if your schema actually fits certain criteria, if you are allowed to make certain queries. And it looks something like this. So at the very base, you're going to start with importing your schema. Because without a schema, you can't test the schema, right? So basically, you're going to feed your schema to Easy GraphQL Tester, and you'll be able to test assertions to it. But for sending assertions, of course, you should mock it, because you have to make assertions with some kind of data in mind. So you can see it on here. So I'm testing a schema. You can see it's a query, and I'm going to send a variable in it as well. And in this part with tester.mock, I'm actually going to send my query. I'm going to send my variables, and I'm going to say I want to mock stuff. So now I'm actually testing if the reviews field of my product, if it will be an array. And you can even extend this test by seeing if it will be an array with a certain length, with certain fields in there. So these are things you can quite easily test with this one just by using this package. And it's going to save you a lot of time writing assertions with maybe Enzyme or Jest or whatever you're using on your side. I'm just going to see if your mock actually returns data. And of course, instead of mock data, you can actually use your real data or maybe even create mock data if you want. Or assertions directly. This is actually something I really like because if you look at this one, it saves you a lot of time. If you look at the previous one, so actually what we're saying here, right here, we have a query, you've defined the abstract syntax tree, and you're just going to have Easy GraphQL tester see if your product ID will return a certain field for something. So now we're actually testing whether my query works. And you can find all information about this package on this website. You can also just go to npm or GitHub and find the project there. So for schema testing, it's really nice to have Easy GraphQL because it saves you tons of times. So resolvers are actually they're a bit different to test, right? Because there are a lot of stuff. There's a lot of stuff at stakes for testing resolvers because maybe you have a database or existing services beneath it. So resolvers they are a bit more tricky to test, but there's one important thing you should keep in mind. Resolvers should be pure functions. You don't want side effects in resolvers. You want every effect for your schema to have its own resolver, and then you probably want to merge them together later on. So you don't want resolvers to be something else than pure functions. And if they aren't pure functions, it's going to be really hard to test them. But it will be even more important to actually test them because if you don't test functions with side effects, you're probably gonna regret it later on. So pure functions and your resolvers actually they should be a black box, right? So you would have this black box, something goes in, maybe it's beer, it's some friends. Everything goes in the black box. And what you want to know is the outcome of the black box, right? But no matter what happens inside the black box, so your pure function, you're pretty sure it will always be fun. So there will be a lot of fun coming out of your resolvers if you put some friends and beer in there. At least that's what I suppose. But so pure functions should be the same way as this black box. So you send something in, and you're pretty sure whatever you send in, it will return something based on what you send in an expected format. And that's what resolvers should do, right? Because resolvers, they should get the information for your schema from your database, for your services, or maybe from computing it somewhere else. So for testing resolvers, it's quite easy to just write assertions. So you're gonna send in, so I have a function or maybe a resolver, invite friends, probably linked to mutation. You're gonna send some variables in there, so 6 friends, some alcohol. It should be a success, right? So whenever you send this mutation, you're probably gonna be pretty sure that you're gonna invite friends, 6 in total with some alcohol. The outcome should be success party, and maybe it should mutate some field. So these are all you should do with your resolvers. So in practice, this means something else, right? Because this is all pure theoretically, but you should also write code to do this for you. So you would have a resolver. It could be something like this. So maybe you're getting reviews for certain products. We just saw someone talking about an e-commerce store. This could actually be a resolver for that e-commerce store if it was written in JavaScript, right? So you're going to send the parent object in there, which is probably product, or maybe it's reviews, some arguments, and the context. And it's going to return probably the reviews. So it's a pure function. There are no side effects. We aren't calling anything in between. And then to test this pure function, you can, if you're using JavaScript like I usually do, or TypeScript, you can just use jest for it. So we're going to test if this resolver will return the reviews. So we have an object. It probably should fit this object. We're going to see if it equals, and it does. So this is all you need to do if you're testing resolvers. So maybe you have some normalizations in there. You probably should test those normalizations as well. And then we get to a bit more tricky part, right? Because we already saw schema testing, which can be done with easy GraphQL tester. We saw resolver testing, which should be done with Jest or whatever is your programming language you're using. An integration test, actually, you're going to bring these two together. So you want to test your schemas with your resolvers with your schemas. You want to test if queries work, mutations work, if they generate the right information, if they mutate, whatever you want them to mutate. So these are stuff you do in integration tests. And like I told you, integration tests, they will be a bit harder to write than unit testing. And you can actually see the schema testing we did as sort of a unit test for your schema. So we're actually going to bring back multiple unit tests together, right? We have a unit test for schemas, a unit test for resolvers, and now we're going to write an integration test that's going to see how they work together. And for this, you need to mock your server because you need to get some information from somewhere. And yeah, so mocking is probably the easiest because if you aren't mocking at this point, you're probably testing against your real server with your real client, which you shouldn't actually want to do. And integration tests are also a bit funny to me because you can test if two functions work together, but it doesn't mean the entire house is built correctly. So maybe you're just testing, oh, I built a new house. Let's see. Oh, I've got working electrics and I got a front door. Doesn't mean you have a house. So integration tests, they aren't like the Holy Grail, but it's a step towards getting to that Holy Grail. So Apollo has some cool functions to do this, to have server mocking and have integration tests. So assume we're using Apollo server. You're just going to set the mocks variable to true. So this is if you're going to instantiate the new Apollo server, you have some fields, some options you could put in there, and you're just going to say mocks is true. So now Apollo server will mock whatever you're using with your schema resolvers. And you can actually try this together with Postman. So I'm using Postman for mostly when I work with REST APIs. I want to get the return of the REST API. But now Postman also have an option to send GraphQL. So you can use GraphQL queries in Postman from the interface. And basically, it means you should have a pretty new version of Postman installed. But it means you can send GraphQL queries just from Postman. So instead of using GraphQL Playground, you can just stick with the tools you already have, like Postman. And I've created a test for this with some code here as well. It's probably easier if I send you a link afterwards as well. So you can actually see the code, see what I did there, and see how I'm testing my server GraphQL. So schemas and resolvers, that kind of stuff. So on the client side, there's other stuff you can test as well. Because so far we just covered servers, and servers are usually easier to test than clients because The only thing that's happens, you have schemas, resolvers, you're sending some stuff on and on. If you're testing client side, we also have to test the tools we're using. So my preferred tool for the front end is React. So which means if I'm testing client side, I should also test React. So I should test if I can send refs, how to handle local state, all that kind of stuff. It will be in your test as well. So client side testing is a bit more complicated. But it probably looks something like this. So what I've done over here, I've used Apollo query component, and I'm sending a query to get some product information. Well, the query component returns me some variables like loading, error data, and I'm going to map those. And this is like a pretty simple front-end application, right? I'm just going to get some data with a query, and I'm going to display it in my application. And something we actually want to test is this component, right? We want to see if our query component returns the query. Henceforth, you want to test the query component actually renders all the other stuff that we put in there, like how to display the products. It should actually render the title in this scenario. So for this, there are things you can use, and something you can use is the mock provider from React Apollo. And also, you should need some sort of testing library for React. So in this scenario, I went for test renderer from React. You can also use React testing library or Enzyme to do this for you. So the first thing you need to do, we actually need to mock the GraphQL client. You don't want to work with the real GraphQL client because then you're probably going to test Apollo's products. Well, actually, they should test their own product, right? So we want to test the code that's in there. So we're going to mock a provider so we don't have to deal with actually live data or maybe any other data that shouldn't be in our mocks. And a test pretty much look like this. So you should mock your data, mock the response of the query component, like we did on the right side. And on the left side, you can see we have a mock provider. We're sending mock data. We're going to render our products component, and we're going to see if our products component is rendering the correct products. So actually, we're going to look for a H3 element, and we're going to find it in our component, and then we're going to expect this H3 element to be displaying the title test. And if this all works, it works. And we can also use snapshots for this, but I'm not really a fan of snapshots. So I would probably prefer to go just by seeing is the title set correctly? Do I have the correct amount of products rendered? These are all things you can easily test client side. And for this, I also created some code. And again, I will post this code later on so you can display it on your own. I will also post it on my Twitter after this. So this is a really pretty basic forward example of testing client-side React with GraphQL. And for end-to-end testing, there is more stuff you can do because end-to-end testing, like we told you, you're going to test the entire chain of GraphQL and your client application and your server together. So for this, we're going to use almost the same tools, except for this time, we're going to be using the actual Apollo provider instead of mocking it. So before we used the mock one, which means we're not really testing a server. This one, we're going to go for Apollo provider, so we're actually going to test our server, which is a bit more exciting, right? Because now a server comes in place. Before we just mocked everything. Now a server might send us some actual responses. And I believe the example for this is also in this code sandbox as well. So if you would open this link, you would go to a code sandbox and you can actually find how to do this. So we covered end-to-end testing. And for dessert, something that I haven't told you just yet is you can also use performance. You can also use load testing to see what your performance of your GraphQL server will be. So in the beginning, I already told you that you could do some other tests server side like performance testing. And for this, there's a package called Easy GraphQL load tester, which is pretty great. Let me see if we can get this up right there. So basically, it's just going to take you some config, and it's the same package as we saw before, but then a different version. So Easy GraphQL is the package that I showed you before to test your schema. You can also use it for load testing. Basically, is this one. And if you are already familiar with load testing, you can see you can already use tools that you use for other load tests as well. Because let me see where it is. You can use it with artillery, which might ring a bell if you've used load testing before. And I believe there's also some other tool you can use it with. Oh no, for now it's basically using artillery IO. So in here you can have some config in there. You can set a duration, like how much you want to test. You can set an arrival rate. You can set some headers, and it's all based on a single JSON file. So you're going to send queries with it, with arguments, get more information out there. You're going to test against local servers. You're going to have selected queries, headers, and this is actually very basic getting started with load testing for GraphQL servers. And if you aren't familiar with this, definitely check it out. Um, because one of the reasons GraphQL servers should be tested really well is because you could get performance issues. If you look at the GitHub API, they actually expose two APIs. One is with REST, one is with GraphQL, and the response limits for the GitHub REST API are way higher than for the GraphQL API. So you can send like 10 times or 100 times more requests on the REST server than you can do on the GraphQL server. And that's because with all those nested relationships, it can get quite tricky to get all the data that you requested. So that's why you definitely should check out load testing. So to summarize what I've told, and sorry, I usually speak very quickly, so it's a lot of information. So to summarize, I talked about testing GraphQL, and we're going to should use static type checking for it. So type checking really is important when working with GraphQL because your schema have types. So probably if your code doesn't have types, you're going to run into problems sometime. We also have unit tests because resolvers, they're pure functions. We can just use unit tests to test our resolvers. And the same goes for the schema. You can also use unit tests for your schemas using the package I showed you. And integration tests, they're one of the most important things to do. So you want to test how your schema works with your resolvers, how your schema works with your client, if your client's actually going to send requests, how to handle those requests. These are things you will do in integration tests. And end-to-end tests, yeah, we saw we can just use them, right? So we can mock our provider when you're using client side. We can also choose to have our actual provider in there and test against our live server, maybe our test server, or set up all other sort of testing principles with both client side and server side at the very same time. And load testing, which was sort of the small dessert I gave you at the end. But definitely check out that package because you might be really amazed by how your GraphQL server performs when using it and sending like 5 or 6 queries at the same time. But maybe you're really shocked. So definitely have a look and see how it actually performs before sending the GraphQL server into production. And the very last thing I want to give with you is 100% test coverage doesn't mean you don't have any bugs. Like bugs will always be there in any code, no matter if the code is 20-year-old or 1-year-old. There will always be some bugs, and testing is a way to reduce the amount of bugs to make your code more stable, to improve your code experience. Um, it shouldn't be a game to get to 100% test coverage because if you're writing one feature and you can test 80% of it, probably that's enough. If you can't test that last 20%, and those last 20% is the most important part of your code, then you did something wrong. Because you should also test the important part of your code, but you don't want to test components when you're probably pretty sure it will render or it won't render. So pick your battles and don't try to get to 100% test coverage because bugs will always be there. Tests should just be there to streamline you and to reduce the amount of bugs. So for this, maybe we can take this one offline. So which do you actually prefer? Do you still prefer the old-fashioned pyramid of testing? Or are you actually going to go with something a bit more modern, where there's like an almost even spread with integration tests, unit tests, and end-to-end tests? Because it takes a lot of time to write end-to-end tests, but they can be really helpful, right? So let's take this conversation maybe to the chat and see which one do you prefer. And so yeah, if you want to learn more, definitely find me on YouTube. Just search for my name and you will find tons of videos about me talking about React or GraphQL. Or just find me on Twitter or Instagram, which you can find me with the username GetHackTeam. Or have a look at these other two websites to find out more about GraphQL and testing GraphQL, both client side and server side. So let's head over to the chat and see if there are any questions from you.
Thanks so much, Roy. I really enjoyed the talk. It was great. I think like testing with such a like new technology as a TypeScript, GraphQL, and React together is something that we have to like figure out. Or the people they have to try to have more information about it in order to adopt into their production ready apps. So is there not there's not a there are not a questions in YouTube right now, but I do have a questions. So lately I've been working on a like kind of full stack developer, a doing always same like GraphQL, like Node and TypeScript in the backend side with GraphQL as an API, and then React, and like a taking advantage of the GraphQL schema as a single source of truth to have a both for both sides, from the server side, from the front side, all my types, as I know that you do. I used to believe in that, which is great. And
Hmm.
but I'm trying to figure out the way that I might have a better, like, let's say, speed when I'm developing new features in my front end side. So let me put you in context. So let's say we are going to have a TypeScript with GraphQL with React. So now in
Yeah.
React we are going to use a let's say Apollo. That's fine. So I know that like testing is super important, and we should do like integration tests, unit tests. But let's say that I'm gonna extend all my types from my graphic schema. So I'm gonna have, let's say that I'm gonna be using GraphQL Codegen, and I'm gonna use a red hooks. I'm gonna type all the return data from my API, and also I'm gonna
Hmm.
have like 100% test coverage in my GraphQL side, in the server side. So if something goes wrong, I'm gonna get even a custom error with a specific error that I had in my backend side, and I'm gonna extend all that information to the front side. So let's say that we have that. So now in the front end side, because let's say if I'm like fetching users, and I'm gonna have the type for it, and I'm gonna have the guarantee that a GraphQL is gonna return me the data that I'm asking for. If not, I'm gonna get a custom error. How do you see
Hmm.
writing unit tests for like simple operation as a fetch data works well when you have to create a new feature? So let's say that tomorrow I'm gonna create a new feature in the dashboard of my application. So would you implement unit tests for, like, let's say that I'm gonna fetch the user and just display them? Would you create a unit test for that, let's say, new feature that you want to implement, or you would rather like be confident in the guarantee that GraphQL is gonna give you, let's say, like GraphQL together with TypeScript, extending those types?
Yeah, probably if you set up your project like that with having TypeScript on the front and back end, and automatically generate your components from your
Yep.
schema, you probably saved yourself a lot of time writing tests that are a bit useless. So that's a good start. Um, so I'm not really sure on your scenario because I guess if you're statically creating those components from schemas, then probably the only thing you need to
Yep.
test is if React is doing what React should be doing.
Okay. So that's okay. The perfect. That's I think kind of a fair question that you really answered it. And then so let's say that I have this component, and that component is gonna have like several states that is gonna mutate the like behavior of that component.
Hmm.
Then is when you are suggesting to do unit testing in order to ensure that that is gonna do that. Let's say like stateful a component container in React, it is gonna do the mutation in the state that it should do. Right? Is that correct?
Yeah, so what you want to test is when you press a certain button, will a mutation will the documented mutation be sent using your query component or whatever you're using. So those are things you would actually want to test. And for the rest, is basically GraphQL should work with that correctly because otherwise there's something wrong with the components you automatically created, and you shouldn't create components that you automatically create because yeah, otherwise you should just write them yourself
Yeah.
if you don't trust them.
Yeah, that's awesome. And just like last quick question, um, are you running low tests, like high performance tests in your current application? And what could be the best way to start with that? Because I didn't do that yet, and I think
Yeah.
I'm gonna do that right after the meetup. Probably.
um, no, so basically, I'm not running them a lot of times. I basically, when I'm constructing a new GraphQL server and I'm testing different ways of schema implementations, that's when I actually use it.
Okay, that's great.
So you want to test your schema implementation when you choose to, um for functions to have its own resolver or maybe have a resolver inside another resolver. Those are ways you can actually test with load testing, see if you could run into any performance issues.
Okay, that's great. It sounds great, and I think easy GraphQL, it helps you a lot in order to set this up, right?
Yeah, it helps you a lot, and basically, um, it's using artillery IO underneath it, so that shouldn't be too hard to get started with as well.
Okay, that's perfect. So yeah, we are gonna go with Kartik now. So thanks so much, Roy, for joining us from
Yes,
Amsterdam.
no
And
problem. Glad to be here.
yeah, like sir, yeah, I will offer you, of course. And yeah, thanks so much for sharing this such incredible knowledge. So now we are gonna jump into Kartik that he's already sharing his screen. And yeah, with this talk, we will wrap it up the minute. So thanks so much, Roy. And Kartik, whenever you are ready, you can just jump in and start.
Yes. So Carlos, can you see my screen?
Yeah, we can see it and we can hear you pretty clearly. So
Okay,
go for it.
great. So let me just get started.
Awesome.
Okay. Yep. Hello, everyone. Warm welcome for everyone who's joining this online meetup. And thank you to Carlos and rest of the team for making this event happen. Um, if you if you guys missed my introduction, I'm Karthik. I work as developer relations lead at dgraph Labs. And all throughout this talk, we're going to learn more about what dgraph is all about. So this talk is about how to build GraphQL API functions for Twitter clone just in 10 minutes. And we'll see how using dgraph, just by composing a GraphQL schema file, we can automatically get all the GraphQL API functions, the correct GraphQL API functions which are necessary, are using which you could build a Twitter clone on your own. So let's just get started. Firstly, who's this talk for? If you are one among those who want to get started with GraphQL in minutes and don't want to worry much about server side, this talk is definitely for you. And having said that, it's not just important to get started fast or getting started in an easy way, but it's also you might be concerned about the scalability and performance of your GraphQL API as your application grows and your application becomes more complex. We'll address that too, and we'll see how dgraph solves all of these challenges. So I guess like now, most of the viewers are familiar with GraphQL schema. So a GraphQL schema essentially represents a graph. So next time when you look at a GraphQL schema, do remember that what you're looking at is a graph. And a GraphQL schema represents your application data graph. Let's learn a bit more about how a GraphQL schema represents a graph, and let's do a live exercise. So let's just compose a GraphQL schema for a tweet. Um, and this is how, in general, this is an approach which you could use in general to compose GraphQL schema for your UIs. And this exercise kind of gives you a streamlined approach towards composing the GraphQL schema, even for the most complex UIs. So let's look at this UI. We all are familiar with this. This is the UI for a tweet, and this is a tweet which we just saw a while back when GraphQL Hong Kong meetup was and an announcement was made. And the first step is to identify all the entities in your UI. In this case, we have a Twitter user who's actually sending out the tweet. In this case, GraphQL Hong Kong is a Twitter user. And what other entities do we see here? Right? We have the actual tweet, which is the second entity. And we also have mentions. And mentions are again Twitter users, right? So even the entity who's posting the tweet is also a Twitter user, and also the mentions are again Twitter users. So we now have two entities. One is a Twitter user, and then the actual tweet. And the third entity could be the hashtags, right? In this tweet, we only see one hashtag. We have two, but in general, you can have any number of hashtags in a tweet. So now we have three entities, namely a GraphQL user, the tweet itself, the Twitter user, the tweet itself, and then we have a hashtag. The next step is to represent all these entities as a node in a graph. So we had three entities, and now we represent all of them as nodes namely now we have user node, tweet node, and a hashtag node. The next step is to see how these different nodes are related to each other. Do we have a relationship between a user node and a tweet node? If you look at your the UI, yes, we definitely have a relationship, right? A Twitter user is a one who actually authors a tweet. So let's represent this relationship using an author's edge from a Twitter user node to a tweet. And next, let's see like from a UI, is a tweet in any way relates to a Twitter user? It does, right? A tweet can mention a Twitter user. So let's represent this relationship between a tweet and the user, a Twitter user, using a mentioned edge. So these edges essentially represents the relationships between these nodes. And again, the relationship between a tweet and a hashtag node is can be represented using a tag with edge. So again, quickly, so we started with our UI, and then we have firstly identified all the entities in the UI. We identified 3 entities. We represented each of the entities as a node, and then we represented the relationship between these entities as edges between these nodes. So the next step is to translate this graph diagram, what we call as an application data graph, to a GraphQL schema. That's relatively easy to do because, as I mentioned earlier, every GraphQL schema essentially represents a graph, the graph of your application data or the data requirements of your UI. So let's see how do we translate this into GraphQL schema. The first step is to represent each of the nodes as types in your GraphQL schema. So we had 3 nodes, and now we represent or we create GraphQL schema types for each of these nodes. And you could see that we have 3 types, that is like type user, type tweet, and type hashtag. And the next step is that now we have the templates for all the types corresponding to each of the nodes from our graph. The next step is to represent the relationship or these edges between the nodes. So the way we represent this relationship is by creating a field for your types where the field would refer another type. In this case, you have type user, which refers type tweet via an author edge. So similarly, if you see the type tweet refers back a type user via and mentioned edge. Right. And the next step, once we have the relationships of represented using the types referring to each other, is to fill in what other fields each of these entities would have and what are its types. For instance, for type user, each user would have a unique ID, which is represented by the GraphQL standard type, the ID type. And then a user would have a username. A Twitter user also would have a user handle, which is a string. And we again have the relationship of a user with a tweet via an authored edge. After we represent the relationships, the next step is to fill in the fields for each of the types. And similarly, we now fill in the fields for the other types, right? We have a tweet has a unique ID. A tweet also has a tweet message, which is a string. I think in the last slide, we missed out on representing the relationship between a tweet and a hashtag. So now we represent that using the tagged with edge. Now we have the GraphQL schema, right? We started with your application UI, and we arrived at the data graph for your UI, and then we represented the data graph as a GraphQL schema. And what you see now is essentially the representation of all the data requirements for your UI as a GraphQL schema. And the next step is just by using this GraphQL schema file, we're going to auto-generate all the CRUD GraphQL functions necessary to build a Twitter clone or to power all the data requirements of your UI. And let's see how to do that using dgraph. And before we do that, let's understand a bit more about what is dgraph in the first place. Dgraph is the world's most advanced graph database, and dgraph is open source. It's a transactional and distributed native graph database. And here is what's exciting for the folks from the GraphQL community. dgraph is the only native GraphQL database which natively interprets and distributes, stores, and executes GraphQL, which means that GraphQL is a first-class citizen for dgraph. And GraphQL is not an additional layer on top of the database. You might have used other database alongside GraphQL by having an additional GraphQL layer on top of the database, which translates the client GraphQL queries into the corresponding database query language. But in case of dgraph, GraphQL is just built in right within the database, and GraphQL is a first-class citizen. So yeah, there's no layering required, and dgraph is also built from ground up to serve GraphQL like workloads. So with dgraph, all you need to know to get started is just GraphQL. We're gonna just see, soon see it in action, wherein we'll take the GraphQL schema file which we composed and just hand it over to dgraph, and dgraph out of the box auto generates all the GraphQL CRUD functions you need. And then as your application evolves, when you need new product features, all you need to do is again come back, edit your GraphQL schema file, and iterate on your APIs. So not just you can get started with GraphQL, you also iterate when using GraphQL. And dgraph, the database admin endpoints are also GraphQL. So which means like all the database operations you can perform using the GraphQL endpoint which dgraph provides. And dgraph is built, every database is built for a very specific kind of workloads. And in case of dgraph, it's built from ground up, it's built from scratch to be able to efficiently serve and scale for graph-like or GraphQL-like or graph traversal-like workloads. So if you are a GraphQL user and if you're building GraphQL applications, the kind of workloads your database would be operating in once you have a lot of client queries coming in because you're using GraphQL in the front end, dgraph efficiently resolves all the data requirements of your UI in one network call in one shot, because that's what it's been built from ground up to serve efficiently and scale for. And okay, let's just see it in action. Let's run dgraph. We are using dgraph standalone container. This is not a recommended way to run dgraph in production, but this is great for quick start purposes. So let's start dgraph. So the database is up. And so this is the GraphQL schema which we just composed, which represents the UI for a tweet. And the next step is to submit this GraphQL schema file using a curl request to dgraph. So let's do that. So this is successful. We just submitted this GraphQL schema file. And now you can use any of your favorite GraphQL editors. We'll use GraphQL Playground. If you're just powering up your GraphQL tool or GraphQL Playground, just point it to http:// localhost 8080/GraphQL. So let's just look at the introspection, and you could see that dgraph has auto-generated GraphQL CRUD functions. Now, for each of the types which is submitted to dgraph auto-generates 5 GraphQL functions. For instance, corresponding to the type user, we have get user, query user, update, delete and add user auto-generated. And similarly, you can see that corresponding to the type tweet which is submitted, we have get tweet, we have query tweet, we have add tweet, update tweet, and delete tweet. So as I mentioned, for each of the GraphQL type which you submit, dgraph auto generates 5 GraphQL CRUD functions. So now let's just add some tweet using the mutation. Let me just quickly see. There seems to be an error. Okay, I just see that a value is missing. Let me just quickly grab the mutation from the schema again. We have the mutation. Oops, there seems to be an error. Because type tweet requires a value for field author. I think we're just missing. Okay, let's just move forward. I think it's just an issue with the mutation format. And basically, once you submit the schema, dgraph auto-generates all the CRUD API functions for you. And then once you have the CRUD functions, let's say you start to iterate on your application, and then you have a new requirement for your app, that is to be able to have a search feature for your user handle. So it's very simple now. All you need to do is just come back to your schema, just edit the schema, and add a simple directive to your schema. In this case, we add @search by hash, and just adding this entry, making this simple edit to your schema, gives you ability to search for users based on the user handle. So just go back to the schema and just make this simple entry. So let's just grab the schema change for user handle and go back to our schema. Let's add this, save the file, and let's just resubmit the schema file to dgraph. Okay, so this is successful. So now, just on adding a simple directive, you would be able to query for the user, right? So you can add a filter to say, hey, by the way, find the user by name Hackintosh Rao and give the user's information, and you can then request for all the tweets the user has authored, and then you can even probably request for the hashtags of those tweets. So have tagged with and then hashtag. And the introspection makes it really easier to be able to get all the auto generation recommendations while you compose your schema or your queries. So let's say now we are able to search for user based on the user handles. How about that your product now needs a new feature to be able to search for user by user names too? Again, pretty simple. Come back to the schema and just add a new directive, search for user by hash. Hash essentially sets an hash index in the database, which allows you to search user by user's name. So let's just do that. So let's just make that simple addition onto our schema. And now let's just resubmit the schema to dgraph. And that's it. You should be able to run a query to search for user based on user's name. Similarly, let's say now you want to search for user just by using user's first name or last name instead of the full name. Uh, all you need to do is just again come back and edit your GraphQL schema, right? To change the index for username from hash to term. So this essentially helps you to enables you to search for user based on user's first name or last name or any of the terms in user's name. Need not necessarily use the complete string of the username. So very simple. Okay, just come back, uh, edit the index, resubmit the schema, and now you should be able to search just by using user's first or last name or any of the term in user's name. And similarly, dgraph offers a variety of indices, and it's very simple. Every time you need to add a new product feature, come back, add a new database index to your GraphQL types, and resubmit it, and dgraph rebuilds the index on the live. There's no need to even restart the server, and you should be able to then use a new more powerful querying facilities. For instance, let's say to power your Twitter search, you want to be able to search using a regular expression. For instance, I'm Karthik Graph. Let's say if you want Karthik Graph to be in your user search, in your Twitter search, even if you use a substring of my name, let's say ART. In such a case, you need regular expression search capabilities. Again, very simple. Just come back, add the regular expression index, save, same process, resubmit, then just come back, and you should be able to run this query, wherein now we are searching just based on a substring in the user's name, and as soon as you type ERT in the search box, that you should be able to get the recommendation of Karthik in the list of users you're searching for. Right. So again, with dgraph, as I mentioned, it's not just you can get started with using the database just using GraphQL, but also you can iterate as your product requirements evolves, as your UI requirements evolves, just by using GraphQL. Now, similarly, like we moved on from our last schema to extend the schema to offer new search capabilities. So if you look at type tweet, we've added a full text search for based on the content of the tweet, that is the strings in the tweet itself. And similarly, if you look at hashtag, we added a regular expression based search for hashtags too. So we just looked at few of the database indices which dgraph offers, and every time you come back, if you want to make use of this database index to power your application feature, you just edit the GraphQL schema file. We saw regular expression, hash, now we see full text search, and also dgraph offers other advanced indexes like geo search if you're building a mobile application or a web application which uses location data, where you want to build queries like find me all the restaurants within 1 kilometer of this location, or within a polygonal structure. It's super easy to do that. And we are adding more powerful capabilities, more powerful indices database, and all you need to do is every time to make use of it is to come back and edit your GraphQL schema file. So let's just quickly extend our schema and update our schema with this full-fledged schema. Okay, here we have the full-fledged schema. And now again, just resubmit the schema. And go back to the playground. So now we can do a full text search based on the content of the tweet itself. which was not possible before. And all we had to do to enable this feature is to add a very simple directive to your graphical schema. So let's move on, and let's just have a quick recap, right? Now, with dgraph, all we did to obtain the CRUD GraphQL functions is to compose your GraphQL schema. So if you're an app developer, if you're a GraphQL developer building your mobile application or web application, start with your UI, identify the entities, get your application data graph, and convert that into a GraphQL schema. And then that's all you need to get started with dgraph. And dgraph gives you full-fledged um, CRUD GraphQL functions to build your applications. And all of this from just your GraphQL types. Right. Yep. That's all I have for this talk. And please do check out dgraph's website to go visit dgraph.io. And more specifically, if you are interested about learning dgraph's GraphQL capabilities, you can take a look at dgraph.io/GraphQL. And dgraph is open source. Please do feel free to go download and try dgraph. And I think the easiest way for you to be up to date with all the updates from dgraph labs is to follow dgraph labs on Twitter. Please visit @dgraph labs, or you can follow me on Twitter at @hackintosh Rav. That's Hackintosh Rav. That's me. And other two resources are to stay up to date would be to follow dgraph's blog at blog.dgraph.io. And also, I think GitHub would be a good place to follow up with all the products development and even the product roadmap. Thank you everyone for your time, and thank you, Carlos, for having me here.
Yeah, it's a pleasure, Karthik. Yeah, thanks so much for joining us and introducing us a bit about the graph. I think it's such a promising technology. And we do have a question for you. So Tobias, actually, he is asking about what is the difference between the term and full text.
Right. Yeah. So these are two different database indexes, and term index enables you to search only based on terms in a string. For example, if this is your string, what I'm highlighting, is my screen on?
Yes, yes.
Okay, yep. Okay, so the term index enabled to search by any of the term in the string, but this terms has to be exact. For example, we have let's say Carlos Rufo. If you are searching for Carlos, you can search for Carlos either by searching for Carlos or for Rufo. So any of the terms in the string. But full text search gives you more advanced string search capabilities. This is more meant for paragraphs of text. Like let's say if you have the information for your entire blog, or it could be a tweet, or it could be a bio, right? And this essentially contains a lot of strings, sometimes hundreds of strings and hundreds of characters. I think full text search is ideal for searching for such entities, where you have a lot of words. And in case of full text search, you need not search for the exact string. Let's say your string says, I am talking at GraphQL Hong Kong meetup today in the evening. You can search for talk Hong Kong graph. That's it. So you need not use the exact strings. You still be able to get this particular string in your search result. So it's a more powerful string search facility or a feature, which is typically used for entities where you have a lot of words. As I said, for instance, it could be a blog post or a bio or a tweet wherein it's difficult to have a lot of characters, a lot of words in it.
Awesome. Yeah, I think it was a really good answer, and yeah, basically I guess it's a different search functionalities depending of whatever you need in that filter, let's say. And to wrap it up, probably the QA, I got a good question. So I would like to know the main advantages of the graph compared to other graph database solutions.
Right. Firstly, dgraph is a native graph database. If you are talking about just graph databases or databases which supports GraphQL, uh,
Okay. So in terms of scalability or like distribution, is there any advantages of the graph?
definitely yes. So firstly, dgraph is a distributed database, and which means it's horizontally scalable, and you can start with one node where you're starting to build your application, onboard your customers. But as your business grows, you can just keep adding the second node, the third node, and fourth node, and fifth node, and so on. It just seamlessly scales, and it's specialized for high throughput, low latency use cases. It's built from ground up to be super performant for uh, graph like or GraphQL like workloads. I think that scalability the graph offers and its performance, I think is something where dgraph stands out from rest of the graph databases in the ecosystem.
Okay, that sounds awesome. So yeah, I think that we can wrap it up for today. Yeah, so yeah, if you want to, you can just like stop sharing your screen, Kartik, and then we can just jump into just like we'll wrap it up probably.
Sure.
Great. So yeah, like thanks so much to everybody. There are another question. What is the testing history for it? Can you have any memory version on it, or can you just put in automatic test? So there are like few questions, Kartik, in the YouTube channel, but you can feel free to go there and just like sit with the Tama sermon in order to answer the
Sure.
question because we are running out of time. And
Yep.
basically, to finish off, I really want to thanks to everybody for your time, for sharing your knowledge. And probably like Tobias, as a co-organizer, he can jump into closing the meetup.
Yeah, thank you, Carlos. I think first of all, thank you everyone for joining. It was really a great time, and I really loved the talks today. Um, and thank you first of all to Engineers Singapore and Michael for making this happen. I think that went pretty well. Haven't had any issues today, so that's awesome. And Carlos, also thank you for being the host today. I think you did a great job. Um, Considering we do this the first time, so it seems like you do it like a lot of times already. So I really enjoyed it, and thank you to Marcin, Kartik, and Roy. We really had great talks today, so really lucky to have those speakers today. And also in regards for the future, we do look to continue this meetup, and we also want to continue to do on-site meetups. Just due to the current situation, we decided to do it remote, but we have the intention to really do another on-site meetup fairly soon, whenever the situation allows it. So give it maybe 2 or 3 months. Of course, it's hard to predict, but we are looking to host the next meetup this year for sure. We will just observe the situation, of course, and then make a decision on when and where we're going to host it. But we will keep you updated. And thank you everyone for joining. I don't know, Carlos, if you want to add anything.
Yeah, no, like like thanks so much for everyone that is just participating in the meetup, from the speakers, sponsors, organizers, the people that they are sharing all this information in Twitter to reach more people, all the attendees online in this case, and it's incredible to see like GraphQL community events like running, whether they're remote, on site. It's great to learn, and I'm super happy to have spent some time with these incredible speakers and of course with attendees. So yeah, like to wrap it up, like I really hope that we are gonna keep doing this kind of like on-site remote events. If you have any question, please feel free to like reach us out in info@graphql-hongkong.org. Please follow the code of conduct. So even as we are remote, please, if there is anything that it might be wrong or something, like just go and like send a message in Twitter, in email, whatever. And if you are if you are trying or you are considering to learn GraphQL, just we are gonna be super happy to provide you the opportunity to speak. We are super welcome to first time speakers. I have such a difficult time in order to find like women that they're willing to speak about GraphQL, but there are not so many, and also the people that are so busy right now. So please reach us out if you wanna give or share your knowledge about GraphQL, because we're happy to set everything up to have you sharing that stuff and just learn from it. So thanks so much to everybody, and hoping to see you soon. Bye.
Thanks, Carlos. Thanks, everyone.
Thanks everyone.
Thank you.
Bye bye.
Thank you. Thank you, everyone.
Thanks.